Hi Math 3 students. In the second video I'm going to take a look at the same problem that I just used to show how to find the perimeter of an irregular figure or object. This time I'm going to find the area of this object. It's not what the question asks for, but we'll just use this as an example for how to deal with this kind of problem. So again, like we said in the last problem with the perimeter, I have this sort of rectangular but kind of rounded off shape here, and I don't have a formula for finding the area of that shape exactly like this, but I do have formulas for finding the area of a rectangle, and I have a formula for finding the area of a circle. So if I can think about a way to sort of break up this shape into some rectangles, and I can see a couple of ways that I might do that. There's some big rectangle in the middle here, kind of little rectangles off on the sides. And I already know that if I put the four corners together, each of these corners is a quarter circle. So if I put the four of them together, I'd have a full circle. So then I can use the formulas that I know, and I can then at the end sort of put everything back together and find the area of the entire shape. So again, let's start with the easier parts. It's a little bit easier to find the area of a rectangle than of a circle. So what I want to think about doing is dividing this shape up into a couple of different rectangles. And there's a number of ways that I can do this. I'm going to, just for example, I'm going to divide it up this way. So I'm going to think about there being sort of a short, skinny rectangle up at the top. I'm going to think about kind of the main part of this figure as being one big rectangle. And then I'm going to think about there being another short, skinny rectangle down at the bottom. And this one is going to be the same as the one up at the top. So I'm going to work on these one at a time. So if I look at this top rectangle, the one that is up here, I'm going to find this area that I'm shading in right now. The formula for the area of a rectangle is area equals length times width. And so I'm going to put that in here. Let's see here. So the length of this rectangle is a length that I actually found in the previous video when we were doing perimeter. And the way that I find that is I know that the entire width of this shape here is 10 meters. I know that there's this little 1 meter piece on the left and a little 1 meter piece on the right that I'm sort of thinking about. It's like I'm cutting that off. It's part of the circular corner of the piece. So what that leaves me with is 8 meters for the length of that long side. I can see here that the length of the short side is 1 meter. So that means when I multiply length times width, I'm just multiplying 8 times 1, which is 8 square meters. I think that looks like a 2. Okay, so let me just fix that quick. Okay, so that is the area of that top long skinny rectangle. The nice thing is that I know that the that bottom rectangle, this one down here, I'll just shade this in kind of loosely. That bottom rectangle is exactly the same as the top one, so that means it also has an area of 8 square meters. So now what I need to find is the area of the big rectangle in the middle. So again here, area is equal to length times width. In this case, the length is the entire long distance across this rounded rectangle shape. So I can say that my length is 10. The width, though, I know that the entire distance across the shape is 6. I'm taking away a little 1 meter piece on one side and a little 1 meter piece on the other side. So that means that the width of this rectangle is 4. So I'm going to multiply 10 times 4, which is 40 square meters. And that gives me the area of that big rectangle in the middle. So this part here. Okay, so everything that I'm shading in now, I've found the area for. So I've already accounted for all of this. And I'm going to total up those areas when I get to the very end of the problem. But before I do that, just finish shading in quick. Before I do that, I have to find the areas of these little circular corners. So this little piece right here, and this little piece here, and this one, and this one. Okay, so I know that the area of a circle, if I put all 4 of these together, I have an entire circle. If I, so I'm going to use the area formula for a circle. Area is pi times the radius squared. So the radius here is 1. So I'm going to do pi times 1 squared. And I can punch that into my calculator, or I can just do it by hand. 1 squared is 1 times 1, which is 1. And if I multiply that by pi, basically I'm just going to get pi as my answer. And so I'm going to round this off. Now this is to round to the 10th place. So pi, if I round to the 100th place, is 3.14. So if I want to round this to the 10th place, I'm going to round it just to 3.1. And that little squiggly equal sign means approximately equal to. So I'm saying that the area of this circle is approximately equal to 3.1. All right, so now I want to find the total area of this entire shape that I've been looking at. And so to do that, total area is going to be the sum of all the areas that I found. So that top piece was 8 meters squared, the middle piece was 40, the bottom piece was 8, and then the circular piece was 3.1. Add these all together. These are all in meters squared. And what I'm going to come up with when I total that is 59.1 square meters. Okay, so again here, the key thing is think about how you can break the large shape down into shapes that you know how to find the area of. Okay, so here I made several rectangles. Then I looked at some little this quarter circles in the corners, put those together into a circle, found the areas that I know how to find with the formulas that I know, and then at the very end, add it all together. Thanks for listening. See you all in class on Monday.